Hello and welcome to the Tech4Climate Podcast. I'm Guillaume, your host, and each week I'm fortunate to share with you stories from climate tech founders, investors, and corporations sharing their unique insights into this fast-moving industry. Eventually, like me, you will learn, discover, and get inspired by those unique men and women who are contributing to the fight against climate change, and I hope it will help you to take a step in this formidable movement. So before we start, I just want to share a few words about us, as this podcast is just the tip of the iceberg of what we do at Startup Basecamp to support the climate tech movement. Our mission is to accelerate capital deployment towards climate tech founders, allowing them to focus on scaling their solutions. How do we do that? Every day, we help founders access to resources and connection and gain the visibility they need to expand their growth. We do this in a number of ways with a membership platform, a Slack group with a growing number of founders, investors, and experts from around the world. And recently, we went one step further with the matching services to connect founders with top climate tech investors. Keep in mind that we are able to do all of this thanks to the support of our listeners and our members. So please like and subscribe, share one episode with a friend, join a community, and if you haven't already done so, make a small donation to support our work. It really means the world to us. And now, enjoy the show! Nice to meet you all. Quickly give you background about Critical Capital Partners, formerly Startup Basecamp. We basically co-invest alongside family office in growth stage, industrial technology and infrastructures in the US market and European market as well. We have a group of like close to 40 family office with who we can structure SPVs, co-investment alongside the lead in four categories or industries. One is the energy sector, the second one is the food and ag. Then we have the built environment and new material, and the fourth one is what we call the industrial processes and circularity. Formerly, we were doing more like deal flow sourcing for a lot of VC funds on the seed Series A stage, I would say, more seed than Series A. In the climate tech space, and then climate tech became a little bit more, I would say cyclic in itself. So speaking with all of those capital allocators, we realized that 75% of them were like still doubting about like where return could be made. So we had to slightly adjust like the terms that we're using, but we invest at the end of the day in the same underlying assets, because any investment that we consider needs to be on one side driven by what we call macro market forces, so everything related to reindustrialization, reshoring, and so on, at the intersection of what we call planetary forces. So we believe that any innovation today, especially in the industrial landscape, needs to factor climate risk. And therefore, or be less carbon intensive and contribute to decarbonization, or on the other side, help on the what we call adaptation play. So it's just a way to speak differently to those large capital allocators to make sure that capital can still flow towards companies like yours. So in the past, we are also hosting this podcast called Tech4Climate. Then I became a dad for the second time, and I had to put everything on hold. So the last one of the last few episodes was with you guys a year ago. So hopefully it will be the restart for the new season. But it should be like episode 100 as well. And I invite you anyway to have a look at the previous interview that we did. We interviewed most of the, I would say, climate tech investors that you can discover today.
And that helped us to build also a tremendous network on both sides of the Atlantic in the space. So that's enough for speaking about me. Happy to jump on a maybe follow-up call with you guys individually later on. So, Beth, you probably shared already my email address as well, the new one, not the previous one. Otherwise, I will be slower to respond. You can also add me on LinkedIn, and definitely happy to see how we can contribute and help you to get exposure into the venture community. So the way we're working today is quite simple. The interview is in two parts. First part is with Beth, and then the second part would be with you guys. You probably read a little bit the blurb and the format of the interview on your side. So I'm going to ask you a 30-second introduction about your company. What is the problem that you're solving and for who? So at that time, if you can also uncover a little bit the market. Let's try to be succinct, not too long, because again, in a format of a video or a podcast that will be also publishing on the platform, it can be hard for people to digest. So the idea is really like giving more like the commercial snapshot of your company and again increasing visibility. Then we'll ask you a little bit also your experience with the Cleantech Open as well, and then more broadly, what's next for your company and how the community of listeners can help you as well. So why don't we start with you, Beth? Are you ready?
I'm ready. All right. Thank you, Guillaume. It's very exciting to be here to introduce the 5 stars of the 2025 Cleantech Open Northeast cohort. They include the National Grand Prize winner, the National Grand Prize runner-up and People Choice winner, and the Northeast winners. In 2025, we had 39 Northeast graduates, and there were 96 graduating teams across the entire Cleantech Open. So we are super excited that the top of the class goes to the Northeast teams. So let me tell you briefly a little bit about Cleantech Open Northeast for listeners who are not familiar with us. Cleantech Open is the world's oldest and largest accelerator for clean tech startups. The Northeast region, which I run, spans from Eastern Canada to Virginia. The accelerator is run in the Northeast by ACT, the Alliance for Climate Transition. ACT leads the just and equitable transition to a clean energy future and a diverse climate economy. The accelerator is like a mini MBA with expert mentoring and lots of professional networking and connections, as well as the opportunity to win cash prizes. The startups work with us for 5.5 months from the end of May to the end of October. The entrepreneurs you'll meet today completed 10 deliverables that are foundational to their businesses, including things you'd expect, like marketing strategy and financial modeling, as well as clean tech oriented assignments such as sustainability plans and greenhouse gas emissions reduction potential calculations. The materials they create are designed to be the beginnings of their business plans, and these materials can also become the core components of their data rooms to share with future investors. To support the entrepreneurs as they progress through the rigorous curriculum, we match each startup in the Northeast with a team of 4 mentors who serve as an advisory board to the teams. The mentors coach the startups through the program, provide a sounding board, make introductions, and often stay in touch with the startups long after the accelerator has concluded, and some of them even join the teams. The accelerator began this year with a 2-day in-person academy in Boston and concluded with an in-person Northeast Regional Finals in New York, followed by the Global Forum at the end of October in San Jose as part of Trellis Impact Verge. At the regional finals, the startups reconnected with other members of the Northeast cohort and community stakeholders, including investors, corporate sponsors, and government sponsors such as the Massachusetts Clean Energy Center, MassEC, NYSERDA, and the New Jersey EDA. At the regional levels, all of the startups were invited to showcase. At the Global Forum, the entire national cohort, along with international clean tech startups, had an opportunity to showcase. The startups you're about to meet were the ones who rose to the top of both the Northeast and national cohorts. Since 2005, here are some stats for you. We now have 681 clean tech startups that have graduated from the Cleantech Open Accelerator in the Northeast. Collectively, they've raised over $2 billion. They're employing over 8,000 people, and their annual revenue is well over $700 million per year. Yes, I believe that's correct. 82% of the founders of the startups in the 2025 Cleantech Open Northeast cohort are women or members of underserved communities. In terms of environmental impact, we teach entrepreneurs how to measure their emissions reduction potential. And to give you an idea of the scope of potential impact, last year, the Cleantech Open Northeast cohort estimated their aggregate emissions reduction potential at 1.39 billion metric tons of CO2 equivalent per year, equivalent to taking 303 million gas-powered cars off the road in a year. So we have yet to tally this year's group, but I'm sure it's also equally impressive. This year's cohort is very well prepared to make a positive impact on the environment and grow the green economy. So here's what I wanted to just tell you a little bit about them. So Evo Natura from Rhode Island is working on biodegradable bioplastics. Gamotech out of Quebec in Canada is electrifying mobile works. Polygon in New Jersey is working on microplastics filtration. Terragen Energy in Massachusetts has modularized regenerative solid oxide fuel cell systems for the growing power demand of AI data centers. And HyGen out of Quebec, Canada, and Singapore has AEM electrolyzers that enable on-site production of green hydrogen that is cost competitive. So stay tuned for their stories.
Fantastic. Thank you so much, Beth. You've been excessively well prepared this year. Like I had no question to ask you at first. You rolled it up perfectly and answering to most of the question. Maybe just one thing. I mean, do you guys also plan to expand outside of the US? And how is the I know we're not speaking about politics here, but did you see a change compared to last, I would say, presidency towards a new one in terms of market traction and thematic that people are talking about?
Yeah, so thanks. Good question. So to answer your first question, we have people participating this year from outside the US. You can see we have 2 Canadian teams here. We also have teams participating from other countries in Europe and Asia this year. And we have had some, in the past, we have had some programming in conjunction with a UN program outside of the US that is no longer active, but we are open to considering how we could perhaps do that in the future, to answer your first question. To answer your second question, we did have what I like to refer to as bookends at the beginning of the program at the Academy, as well as at the end. We really teed up the conversation about the current environment and concluded that at the Academy, at the regional finals as well, regarding what's new, what's different. And this year, definitely there are some differences. There are still, however, some opportunities. The need for the work that these wonderful startups are doing has not abated at all. So a huge need for what we do. We are just doing it with a little bit of a different focus, perhaps. And I think many of the organizations that we work with see the need. We are focused on so many different kinds of opportunities that you'll hear about today. But yes, there are some changes with some uncertainty, but there are also great opportunities. And one of the big ones is with AI data centers requiring a lot more power. And Terragen has a direct solution for that. But there are some other opportunity categories where we really, I think, are leaning in. And I think the microplastics one is another really good example. So you'll hear from Polygon about that. and obviously Eva Natura, and the others are working on solutions that are not necessarily related to, we're not dependent on the federal government for their support. So I think that, I think all systems go as far as I'm concerned. So that's it.
But
Yeah.
at the end of the day, when you're solving like a big problem, and in the meantime, you're also able to generate return for the investors that are behind it. Any companies in any environment should be able to succeed. That's I think something very important to keep in mind. We are also all entrepreneurs looking to build companies that also will create the return and deliver on the impact if they succeed financially.
Yeah.
Thank you so much,
And,
Beth. Very appreciated
just-
for this. Yes.
Yes, and just one other thing. I mean, when you hear from all of them, you will see they all have some kind of traction going on. So these are companies that are definitely poised to be very successful, I believe. So I'll let you take it from here. So thank you again.
Fantastic. Thank you so much. So let's go and let's start with Evo Natura. Boom, boom, boom. Alors, speaking a little bit in French.
That was Alka.
Thank you so much for joining us, and congratulations already on everything that you achieved so far. So maybe you can start by tell us a little bit more about, for the audience, remind them what is Evo Natura, what problem you guys are solving, and for whom.
Absolutely. So we are we're co-founded in Rhode Island, in Northeast Rhode Island, and we are a mother-daughter venture, and we are have invented a smart biodegradation technology that can degrade materials, especially bioplastics, at a very fast speed, as well as safely in all ambient environments. And the reason we're trying to solve this problem is because we know that the alternative to plastics, which is the bioplastics, which is also a huge industry, has a big disconnect and has a lot of problem in the disintegration when at end of use of its life cycle. And what happens is bioplastics can only degrade in industrial composting facilities. And globally, currently, there are only about 20% of the industrial composting facilities that accept bioplastics because of problem of contamination and so forth. So what happens is that they actually land up in landfills. So we want to give bioplastics a better reputation, a better performance. So we have our technology works on proprietary IP pending encapsulation technology, which holds FDA-approved microbes that can be a plug-and-play solution. And so what happens is it basically, you can drop it in the bioplastic manufacturing process. And then once it's dropped there, it is thermally stable till end of life. And once discarded, it actually can, the microbes, the shell actually starts dissolving, and then the microbes become active. So it's like putting a composting facility inside the material. And so it starts degrading the material from inside out. And so that's where we are in our research, and we are currently have gained a lot of traction. We are going to be launching our pilot scaling with a couple of the plastic global giants. So we are very excited to be partnering with them. And the whole idea currently is for us is to de-risk ourselves as well as de-risk them. Because they are very interested. And the reason why all of them are very interested is because there is compliance everywhere. EU has now mandated compliance around the whole biodegradation. No loose terms around, oh, this is what it is and we can just use this. So manufacturers are under a lot of pressure. And our solution gives them makes them compliant, as well as allows them to be able to unlock markets where they have not been able to explore as such.
Mm-hmm. Can just quickly tell me about the economics of it? Like, I mean, how do your innovation compares to traditional like bioplastic today? I mean, what is the green premium, if any, and how do you plan to overcome that green premium?
Okay, so currently we are what we are an additive company, and that's one of the things with when we went through the Cleantech Open. I can address this question is like we were thinking that we were going to innovate our own, novel bioplastic, whole brand new material, and then we realized as we were going through the program and as our research was showing is that we don't need to invent another material. We need to be the ingredient that actually enhances that material to perform the way that it should perform. So we were able to hone in our technology. And right now, currently in the world, there are about only 4 companies working on this. One is based out of France. They do more enzymatic biodegradation. Enzymes are very, very expensive. So it becomes very not cost effective. Now we work with microbes. So microbes are much, much cheaper. It's going to be pennies to the cost of the manufacturers, what they will land up, adding it to the end cost as such.
Fantastic. Ultimate question on your product. Can you tell me like how do you as of today is able to produce those microbes and at scale? Do you have like bioreactors? Like what is the I would say the secret sauce that you have behind?
Yeah, so we're very early stage. We are like in our infancy, yet we have gone from our bench top. Now we're moving it to pilot scale next year. And our secret sauce is basically our encapsulation is what actually holds the microbes, because that's the key thing, is what it is, because the microbes can the technology that we have can withhold very high temperatures, especially during extrusion process. So that allows the thermal stability is very important. And then we can hold that microbe very safely. So our goal for next year is the scale up, and we will be looking at small scale manufacturing. We are looking at a CDMO partner currently to scale up, just to de-risk ourselves as we move forward.
Fantastic. Ultimate question on my side before we move with the other companies. How the community of listeners can help you?
Well, we would love to be, so as we're expanding, our goal for 2026 is pilot scale kind of testing and manufacturing, because our goal is to get as many material companies, plastic companies on board with this. So if you have connections, anyone in this space, we would love to have that conversation with you. We would like to be able to help them to be compliant, given all the new regulations that are happening. And that would be the best, connections are really important for us.
Thank you so much, Alkia. Very impressive what you guys have been able to achieve so far. And it sounds like definitely a large market where a strong solution like yours is definitely needed. So anyone listening to this wants to get in touch with Alkia, go on LinkedIn and maybe cold email her. She will definitely reply to you. Thank you so much. Let's go now with Gamotech.
Thank you.
Bonjour Guillaume.
Hello, hello.
Hello.
Nice to meet you, Oliver.
Nice to meet you as well. Yes. So today I'm here in New York City, probably in the Ghostbuster building, and I'm here to talk about my startup Gamotech. So
fantastic. Do you mind eventually? Do you have like another position where you don't have the window background, because it just makes you a little bit more like Yeah, I think that's going to be a bit better. Just for the lighting in itself was better as the video is recorded. You look fantastic, Oliver. So just you were not maybe you were there at the intro when I
Yes.
covered okay, fantastic. So let's move on then. If you can tell us a little bit more about Gamotech in 30 seconds. What is the problem that you guys are solving and for whom? What is the market that you're tackling?
It's great. So vocational trucks are used to perform work that is mobile in nature. You will find them in municipalities for fixing waterworks, in utility grids to service the network, as well as on construction sites. These trucks are expensive, and the power used on those job sites mostly come from the engine of the truck. This is a loud, unsafe, and very expensive way to bring mobile power. At Gamotech, so we manufacture power units to electrify all these power applications, bringing clean, quiet power, as well as improving lives of workers and cutting down the cost of mobile power equipment.
Fantastic. So where are you at in terms of like prototyping? And if you could like just maybe uncover for the audience a little bit like the different steps that you went through it and like what were the different challenges that you overcome?
Yeah, so we're based in Montreal. We have a small team of around 10 people. The first challenge for sure was to find the first niche market segment that we could enter this. This is a very highly fragmented market where every city has their truck modifying upfitting company and everybody is kind of reinventing work trucks every time that they install some equipment on them. So there's no industrialized way to do this. So we finally signed in 2024 our first pilot project where we electrify the waterworks trucks for municipalities. So basically, it's a truck that is used for pumping water in an excavation and replacing a broken water pipe that is there. So every city has to maintain their potable water network. So that was very successful and it ran for a year. And since then, we have 10 customers so far for municipalities. And we're starting partnerships with electric truck manufacturers to integrate into their system. So now we have a small factory and we're in production right now. So
Fantastic. Can you give us a bit more details about the electrification process? I mean, what is the IP and secret sauce that you have behind that?
well, we are exploring the market and developing new solution and then patenting what we find because it's kind of a greenfield market. There's not much yet in the patent side for the electrification on the back of the truck. So our first technology that we developed was a more efficient way to convert from batteries to hydraulic power because a lot of those equipment on the back of the truck are already powered by hydraulic. So that was the first one. Second is we realized that we could bring more power to the back of the truck so that we can electrify bigger equipment for a longer time. But these trucks are expensive, so we invented kind of a multi-mode swappable back of the truck system so that you can have different plugins like for watering plants or for changing light bulbs, or there's an aerial lift. So we patented this swappable energized plug-in for electric trucks, and we're continuing to develop new solutions. Now we're into the air compressor segment where because a lot of construction sites need compressed air, so we're investing into improving how this is electrified mobile in a mobile way.
Okay, but so just to be clear, it become the truck become an hybrid truck, so it's still like a fuel engine that move the truck around, but on the other side, any equipment that required prior to that energy from the fuel engine of the truck is now electrified, correct?
So we are trying to, of course, to decarbonize the whole job site. But by taking control of the mobile power, we are completely disconnected from the truck itself. So there is a big saving right now to install our units into mobile trailers so that you can completely disconnect and leave the mobile unit on the job site and the truck can go on to do other things. We're also installing on electric vehicles. So using the synergy of the battery that's already on the electric truck to power our equipment. And third, we are also doing hybrid systems for application that need longer mileage. Okay, so they need a diesel truck to traverse the distance, but when the truck is stopped, then our application is electrified. So there's three applications on it.
Fantastic. And tell us a bit more about the production line that you have. I mean, you mentioned that now you're in production, you have like 10 different clients. Like, where is it based, and what's next for the expansion of it?
We're based in Montreal, so our customer base for now is in around the Quebec province. We we had one first customer in California, and now I'm in New York to expand here as well. The challenge for us is industrializing a market that is very custom based. So every unit that we develop, we improve the standardization of the components, and we're building key components that we can plug in together to address different types of solutions like dewatering or plugging a bucket on the truck or things like this. So every time that we advance, we're industrializing more and more so that we can industrial the parts, but as well as standardize the assembly line. So we are at this stage right now where we are focusing a lot more on the production phase.
Cost-wise, are you guys at cost parity with the traditional fuel-based power system, or it doesn't really matter at this stage because local regulation enforced to have less emission on the truck side?
We do find that in California there is this regulation, except California, the regulations are not totally there. So that's where we're focusing right now on the low-hanging fruits, where we are cheaper from the get-go. So in order to do this, that's why we focus on mobile applications that are fixed at a location during the job site. So I mentioned waterworks, so you can stay there for 4 or 5 hours. So by doing this, we convert a six-wheeler into a trailer format. So we save directly $150,000 on this type of application from the beginning. So we're also exploring pipeline service units. So it's the same thing as waterworks. So we will first focus on the place on the market segments that we can reinvent the work unit to make them cheaper from the beginning. Otherwise, on the OPEX sides, we're saving anywhere from $10,000 per year to $60,000 per year in fuel, and we use our energy to improve lives of workers. So we increase the retention as well because it's quiet, and we bring in air conditioning. There's no more fumes. So we're doing these cells so that we can survive and grow without the regulation support.
Fantastic, very exciting. What's next for you guys?
For us, it's planning our U.S. expansion. So it's because U.S. market has more higher volumes of a certain type of application compared to our small market up here in Canada. So that's where we're looking to expand here, so that we can increase our standardization by bringing more volume, and also in order to look for more financing so that we can grow our operation from coast to coast.
Fantastic. How can the community of listener, investors, founders listening to the show today, the video, can help you guys?
We are driven by pilot projects and by technological demonstrations. So if you know any municipalities or fleet construction trucks or utility grid pipelines that want to innovate, that want to decarbonize their fleet, but there is always missing a link. Well, Gamotech is the link, so please refer them to us so that we can work together and demonstrate one project, because in each region we have to start not from scratch, but at least we need to build the trust locally that we can do it. So we need people to open doors, because these organizations that we target are quite large, so it's not easy to get the trust to get a good conversation going.
Fantastic. Congratulations, Oliver. Very exciting what you guys are doing with Gamotech. Sounds like there is a lot of potential, and you're definitely bringing an interesting business case with a strong impact as well for the companies saving money, but also the workers being more happy and staying longer. So very exciting. Thank you so much. Now we're gonna move on with the Polygon system.
Mm-hmm. Hi, nice to meet.
Hello, Nathaniel.
Mm-hmm. Yeah, so I guess I can give a brief rundown on the work we're doing at Polygon. So we're a company dedicated to solving the problem of microplastic pollution, in part at least. Microplastics are really just any plastic particle, fiber, piece, fragment smaller than 5 millimeters in size. And the reason they're problematic is twofold. Firstly, they're everywhere. They're found in all our waters, all our oceans, lakes, drinking water sources, and unknown to deposit now in human bodily tissues. And secondly, the additives inside plastic are now becoming more known to be harmful. So they can contain things that are carcinogenic, neurotoxic, or endocrine disrupting. So if things really aren't done to start removing microplastics, they can pose a major health hazard. And the reason why our technology is unique in really solving this is traditionally, the things that are really used to capture plastics are things like trash trappers or reservoirs and rivers. These really don't remove microplastics. They really aren't designed to filter things smaller than a couple millimeters in size at smallest. And in water treatment, things like reverse osmosis, granular activated carbon, these traditional sort of filtration methods are incredibly expensive and energy intensive to install and maintain. So these things cost millions for municipal scale operations. And so cannot really be deployed, especially in areas which are less affluent or use older infrastructure. So inside water treatment applications, it's not really a scalable solution. So what we've developed is a new type of filter media that can capture over 98% of microplastics from gravity flow. So it requires no electricity or pump systems to filter out the plastic. And that way we can actually remove the vast majority of microplastics from both open source environments and treatment environments, whilst using 1/10,000th of the energy of something like a RO system or a granular activated carbon system.
That's very exciting. So can you tell us a bit more about like how does it work? You mentioned like if today, if I understand well, first of all, you're addressing like more like municipality filtering water. So I guess that's where Polygon can fits the best at first. Do you integrate yourself with existing infrastructure, or you need to be an addition and maybe a divert pipe that filter the water through your system? Can you help like the audience that didn't go to your website or didn't see your presentation to figure it out, like how the flow works?
Yeah, so in general, so we've done the world's first pilot to remove microplastics from wastewater. So we know exactly where this thing actually fits. So really it's at the end of secondary treatment as an addition. So what we'd do is we'd have a modular like box containing our filter media that really goes at the effluent, so at the treated effluent of a treatment facility, and it will introduce our filter media exactly as that water's outflowing. It would just run through the filter media, doesn't once again require any electricity for the actual filtration. And then when the media needs to be regenerated, that box of media basically gets removed, cleaned, and reinserted. So it's a very energy efficient system that can just be quickly added onto existing infrastructure without any significant construction. You just ship over, like it would basically come inside a shipping container. You install it at the end, and within a day you can have this thing operational. One thing to mention is actually when we were going into the Cleantech Open, we thought municipal treatment was going to be our primary market because that's where we did our pilots. That's where we were sort of getting a lot of our data from. But one of the challenges in that sector is it's a very slow moving sector. So it's one, you need a lot of permitting time, a lot of approvals. It's also very regulatory driven, and the regulations on microplastic are fairly nascent. So one of the things we went into the Cleantech Open like asking when we were going with our mentors was like, right, what are the ways we can scale this thing effectively? What are the different markets that we can really address with this? And one thing we learned over that period is actually there's a huge potential market in consumer packaged goods and textile treatment. So when you're actually producing goods, there's huge amounts of microplastics that are emitted. So if you're producing clothing, for example, the wash processes emit loads of fibers. And there's already regulatory on that front, really mandating that these fibers be reduced in production lines. So, over the last few months, we've developed like an inline system, so a smaller scale system designed sort of like a cartridge that goes at the end of industrial production lines. And that one seems to be getting a huge amount of traction. So we already have like MOUs with H&M, Lululemon, and we're in very close talks with Nike at this moment as well about that.
Okay, very, very interesting. And can you tell us a bit more about like how does it work? Like you need to how do you? I mean, is it like a cartridge that you remove and change, or how do you clean those filters? Like, and how long does it take to be clogged of microplastic? Because I mean, I believe at some point of time it gets full, needs to be cleaned up or regenerate. That's probably the word that you used.
Yeah. So yeah, I mean, it depends on the environment and the amount of like if there's loads of plastic in your water, it'll clog up faster. If it's also got like large volumes of water it's treating, it'll clog up faster. So our initial pilot was actually a very large pilot. So we were filtering around between 20 and 30 million gallons of water per day with our first pilot. So it's very high capacity. In that case, we were initially expecting to have the filter be regenerated once a week. The reality is actually it needs to be regenerated around 2 to 3 times a day. So what we've developed is basically an automated system that does it. So an operator doesn't need to be involved, but basically it'll automatically remove the media, do a 2-minute cleaning process, and then reinsert it. So that's how we do it for municipal scale systems. For industrial scale, like they have very high concentrations of microplastic, but the volume of water is a lot lower. And the type of system we've developed is different. So that one is very much like a cartridge. Imagine something similar to like a standard granular activated carbon cartridge. It'll be similar to that. And in that one, we can just backwash it. So every time that saturates, which is actually around once every 4 or 5 days, it saturates, you just backwash it, and then you can collect the plastic from that in a concentrate. And that takes around 10-15 seconds to do.
Fantastic, very interesting. Can you tell us a bit more about the economics of it? I mean, how do you guys make money with that?
Yeah. So we run it kind of as a razor blade model. So we install an initial system on site. They pay for that system upfront, and then once it's in place, we would then charge for filter media replacements on an annual basis. So the actual filter media is fully recyclable and is meant to have around like a year-long lifespan. It can vary a little bit depending on application, but generally around a year. So every year we'd replace the media, and we also charge if anyone wants to have data reporting. So a lot of the things we found is loads of groups, especially industrial players, really want to have the data on what precisely are they collecting. And we can actually provide that by taking regular samples from our media to sort of see, what is on it, how much, what types of plastic, and we provide that as a service as well.
Okay, fantastic. So what's next for you guys?
Yeah, so we're at a really interesting inflection point. So I think the municipal treatment is taking off at the same time as the industrial players. So we have around 1.2 million in revenue from 2 municipal clients this year. One in Atlantic City, one in California, and then on top of that, we're in discussions with, we're doing studies with H&M, Lululemon, Nike is another player we're in discussions with. So we're going to be visiting their facilities in early 2026 to do initial installs. And we also recently got a contract with the food and bev sector, specifically with one group called Way Out Water and another group called Carita. And in both cases, we're exploring applications of this cartridge model that we developed under the Cleantech Open to actually filter in the case of Way Out drinking water, in the case of Carita, some of their industrial water for cooling towers. So there's different applications there that we're looking into, and those are going to also happen in 2026. So 2026 is a really big year for us.
Fantastic. That's very exciting. How the community of listeners, investors, founders listening to the show can help you today?
Yeah, so there's a couple things. I mean, same with everyone else, connections is going to be really important. So having like being networked to potential clients, so especially in the consumer packaged goods, textile sectors are two ones which we think would be very high growth. So any connections there would be fantastic. We also want to find, I guess, companies that we can work with, because now we're actually starting to collect these plastics at scale. We need to know what to do with them. So it's not really my area to sort of figure out the exact recycling of these microplastics, but we can be key suppliers to sort of test, can we upcycle this waste that we're collecting so we can actually make it a truly circular system. So finding partners there will be very important. And lastly, I guess we're just launching our microplastic analysis as a service. So any groups that want to sort of see, is their water contaminated? We can analyze that, give you the data. And also various companies, they want to prove that their products are microplastic free. And we can actually do samples analysis and provide certifications if it is indeed free of microplastic. So those are things we're also willing to offer anyone that's interested.
Fantastic. Thank you so much. Very impressive what you guys are doing. microplastics is unfortunately a massive challenge for the whole human species and all the other like animal livings on this planet. So thank you so much for taking that fight forefront. And I think the market is definitely opening up for this kind of solution. There's no way around it. So congratulations.
All right, thanks so much.
All right, let's go with TerraGen Energy Corporation.
There it is.
Hello, Joshua.
Okay. Yeah. How are you doing?
Pretty good. Thank you.
Good. Yeah. Thank you for doing this, and thank you for helping with the Cleantech Open. That's a great thing for us.
It's always a pleasure. It's been a long relationship with Beth, and always like impressed by all the companies that they're able to support and in somehow incubate or accelerate. So congratulations to all of you guys, because that's the work that you're doing. So tell us a bit more about TerraGen.
Yeah. TerraGen Energy is solving a growing challenge of delivering fast, reliable, and affordable clean power and energy to the grid where generators and batteries can't, right? I think specifically, we see the near-term targets as data centers, microgrids, and industrial users. They all need 24/7 power. And the issue is that batteries alone can't meet the duration that's required for these things to go green, and generators don't store energy. And so our solution is a reversible solid oxide system that acts both as a power generator and as a long-term energy storage device. So we can do both of those models and both of those solutions in one reactor. So kind of get one system, two functions, zero compromise on the performance and clean attributes.
That sounds like too good to be true. Can you tell us a bit more about like how does it work? I mean, for people again listening only the show, and here you're not sharing any visual as well. So tell us a bit more like how does it work exactly, and how does it look like, and how you guys have been able to put that together.
Yeah. It does almost sound a little too good to be true, right? So at the core of our system is a new type of reversible system, new type of solid oxide cell that was invented at Lawrence Berkeley National Lab. And one of our co-founders, Rufan Wang, was actually one of the inventors of that technology at the National Lab. So I think that too good to be true. It's like when you put the best and the brightest scientists in the US at the National Lab, they come up with stuff that is amazing. And so at the core of this metal supported cell is a very thin ceramic electrolyte, which allows us to conduct oxygen ions. And that means that we can process gases, whether it be propane, natural gas, or just hydrogen, electrochemically, and avoid the combustion route that you see in like a diesel generator or a gas turbine. That means it's much more energy efficient. It's also quiet, right? There's no mechanical moving parts, so you have a much more durable system.
That's fantastic, but tell us a bit more about like then the cost. I'm trying to understand like where's the catch here?
Yeah. So cost wise, I mean, one of the things that makes this so attractive for us is that we really targeted a technology that could solve this fuel cell problem and be cheaper than the incumbent costs because of the material choices. So a standard fuel cell or standard solid oxide cell is a very expensive ceramic that's rare earth doped. And many of these systems, like a Bloom Energy system, uses a 200, maybe 100 to 200 micron electrolyte supported cell. That's a lot of material and a lot of rare earth, and it also leads to a very low power density. Our technology uses a 10 micron ceramic membrane of that, and then supported by stainless steel. Ubiquitous, cheap, easy to get a hold of, easy to recycle, and easy to process. That leads to a very large cost reduction from a few different avenues. One, we can achieve pretty high power density, which means the overall number of cells shrinks, the stack in the system shrinks. Two, because it's a very thin membrane, the amount of rare earths used in that system is significantly lower than in a competitor technology. And third, that stainless steel just generally is much more cost effective than the rare earths or the doped ceramics.
Okay, fantastic. So tell us a bit more about like your beachhead market. I mean, who is using it? Which sectors, which type of client? Tell us a bit more. Help us to understand like how this could be better than just being in a lab, you know?
Yeah. So we think for us, one of the beachhead markets really is around data centers and electrification. These are customers with a real need for power and energy. And because of the reversibility, right, we can come in early and deliver that power when they need it right now while they're waiting for other connections, for grid connections to do that. And then once that grid connection comes in, we can transfer to an energy storage mode where we use that same reactor to firm up wind and solar, making that a firm power source. And so we see those as very early adopters. Also, microgrids and smaller implementations where they want to go off grid, they have access to natural gas, or they already have solar and wind facilities available.
Okay, fantastic. And are you guys already more than in discussion with some data center providers, or it's still like really the pilot phase? I mean, how large is the scale as of today that of the is it pilot or is it more than pilot? Is it like full scale?
No, so we're pre-pilot. We're actually building our first demonstrated reactor right now. During the Cleantech Open, we actually moved into a new lab and pilot manufacturing space. So we were in the process of signing our first MOU for a 2 to 5 kilowatt demonstrator that will go out in the field in 2026. But the scale for some of these data centers is huge, right? We see those as kind of a minimum of around a 1 megawatt reactor. And so we've got a very fast path, but a big path to go from a couple of kilowatts to a couple of megawatts scaling.
So what's the next step in a way to de-risk, or where do you see the potential bottleneck, and how do you think you're gonna go around it?
Sorry, can you repeat that?
So scaling from few kilowatt to like megawatt in itself, like how do you foresee any like potential, do you foresee already today like potential bottleneck or like challenges that you're gonna need to overcome, and do you have already like this more like a road in front of you in terms of like scaling that to the megawatt? That makes sense.
Yeah, so I think scaling is always a challenge for technologies, especially technologies coming out of like a national lab where the focus really is on the science and the physics of how the material works. One nice thing about the stainless steel and using these kind of known ceramic processes is that they're already used at scale, very, very large scale for similar products. And so we don't think the manufacturing scale will be the bottleneck. We actually think the bottleneck will be more on getting customers to adapt new technology quickly at that scale. Things like data centers or critical infrastructure, they have a very, very high bar for reliability. And so for us, the challenge is getting enough test data and enough pilots into the field quick enough that they can see that and have that confidence and faith, right, to test the bigger systems.
Fantastic, very exciting. The economics behind it, like, I mean, you mentioned already that you're able to save a lot in terms of like rare earth, in terms of like, the stainless steel that you guys are using and so on. So do you see that it can only work for data centers, or it can also work for smaller application?
I think there is sort of a minimum size where it really makes sense, probably around 25 kilowatts. Very small systems, kind of require a different approach to developing the technology and deploying it. So we're not going after, in the past, people have heard about fuel cells for your cell phone or for your laptop computer, for your car. Those are very important markets, but that's not where we're really focused. We're really focused on driving these large systems because one, we see the economic benefit, but also the green impact is huge for those customers.
Makes a lot of sense. So what's next for you guys? Despite all the plans, I mean, you just moved into the new facility you mentioned, new office. So how can we help you?
Yeah. So what's next? We're right now we're really focused on scaling from this lab prototype up to our 2 to 5 kilowatt pilot and validating that. We're signing our first MOU to get these out into the field with a partner and get some critical test data. And so, I think kind of for us, the next step is to build those prototypes and get those out there, shore up the supply chain side, and continue to grow the team in that manufacturing space.
So how can we help you?
Yeah, I guess I think a couple of ways, right? We'd love introduction to more pilot partners, potential hosts, microgrids, people running data centers, or anyone who needs fast, reliable, affordable, and clean power and energy. Also, we realized, through the Cleantech Open, that the markets we're chasing are markets that have a huge impact on the local community around where these data centers are built or where these big industrial energy users are. And so we'd love to engage with the community leaders and the community movers and political leaders in that area to really better understand how we can help not only the customer specifically who's buying it, right, but that greater community. And then lastly, I'd say we're hiring and we're building the team right now. So we're really looking for referrals to candidates with a deep understanding of prototyping, manufacturing, stack design, electrochemical testing, to come on early and help us scale this.
Fantastic. Congratulations, Joshua. It sounds very exciting what you guys are building. Again, fourth company that goes here on the show. And I definitely want to keep following you guys and hear as well more. And if anyone on the show has like any opportunities for pilot testing or helping on the hiring side, please feel free to reach them out. So congratulations.
Yeah, thank you. Thank you.
Fantastic. And now we're going to finalize this episode with Jen.
Bonjour. Hello.
Hello, Natalie. How are you?
Hello. I'm very well, thank you. How about you?
Pretty good. It's been a very pleasant episode so far, like listening to all of your innovation and incredible stories as well. Very exciting for me. So thank you so much, and looking forward to understand a little bit more about what iGen does.
Absolutely. Thank you. My pleasure. So HyGen is, we work in the green hydrogen space, as our name sort of suggests. And so just to give a little bit of context, hydrogen as a consumable, as a feedstock, is used in a number of industries, everything from chemicals and polymer production, semiconductors, electronics, all the way to steel manufacturing, food and beverage. So we don't really think about it as a consumable. We tend to think about hydrogen as a mobility and transportation market, but actually hydrogen as a consumable is used the world over in so many industries. And of the 94 million tons of hydrogen produced today on an annual basis, the vast majority, over 95% of it, is actually gray hydrogen. So it's derived through the use of fossil fuels, mostly through a process called SMR, so steam methane reforming. And it's made in centralized locations and then shipped across the world to the end industrial users who need it. So this shipping and transportation not only adds significant safety risks, but also emissions and costs. And actually, transportation and cost can account for up to 70% of the landed cost of hydrogen. So we tend to use the excuse, I think, as a society, we use excuse that green hydrogen will never be cost competitive because gray hydrogen costs $2 a kilo. And that's true if you have your own SMR refinery right next door to you. The landed cost, I like to say, well, check your receipts. That's not actually what you're paying for hydrogen in the end. So HyGen has developed a novel technology in anion exchange membrane electrolyzers that brings the landed cost of hydrogen down, because then we can allow for these industrial players to produce their own hydrogen on site, on demand, as they need it. We're reducing safety risks because they don't have to store it if they don't want to. They can just turn it on and off as they need the hydrogen. It has a much higher purity as well than gray hydrogen. Gray hydrogen, since it's derived through the use of fossil fuels, has a lot of impurity. So most of these industries have to purify it on site. Things, especially when we're talking electronics, semiconductors, lab-grown diamonds, they require an ultra-high purity hydrogen. So using our technology, not only is the process entirely carbon-free, but it also gives a very high purity hydrogen directly to the user.
So tell us a bit more about the user. Like, what is your beachhead market for iGen today?
Well, today our beachhead market are semiconductors, lab-grown diamonds. The reason why we have targeted these two specific beachhead markets is that they require very ultra-pure hydrogen, as I mentioned. They have small to medium size requirements, but consistent requirements of hydrogen. So they tend to, most of their reactors run 24/7. So they need a consistent supply of hydrogen, but it's not a huge supply. So we can already sell to them with our current capacity systems. So we have AEM systems that go up to 100 kilowatts. We also make PEM systems, proton exchange membrane, which is a more established technology. If you think about an electrolyzer stack, it's sort of like a sandwich, and the basic construction is pretty much the same. It's just the components within it, the elements are different. So our production line can produce both. So if we have a client that maybe is a little more averse, as Tara-Jen was mentioning, a little more averse to newer technology, we can still service them while showcasing the advantages of AEM. But that being said, those are our beachheads for those simple reasons: the purity and the consistent smaller requirements, which makes our system very cost competitive. Because when they buy their hydrogen through cylinders, they don't have the advantage of large bulk deliveries, so they don't get that cost competitiveness of buying large quantities. So our systems tend to be very attractive from a financial perspective. And then that's our beachhead.
Okay.
But then obviously, as we move forward, 2027 and beyond, we'll be taking on larger industrial players, chemicals, polymers, plastics, food and beverage, pharmaceuticals, and then steel, mobility, and everything under the sun. As our stack systems grow, we'll be able to become more cost competitive for the larger players as well.
Okay, fantastic. And I mean, tell me a bit more about how do you produce those electrolyzer? I mean, do you have like a production line already in place?
We do.
And
We
tell us a
do.
bit more
We,
about like the business model that you guys have.
Of course. So we are a global and distributed team. I'm located here in North America. We have our main R&D team that is in Singapore. We are actually originally a spin-off of the National University of Singapore. Our two co-founders met there. And our manufacturing line is in Mangalore, India, where one of our founders is located. So we have there are over 20 of us on the team, and our manufacturing facility is where we build all of our systems. So we, from a business model perspective, obviously our IP, we currently have 6 patents pending and another 5 coming before the end of this calendar year. Our IP is on the stack itself. And it's across the entire stack. And that's one thing that's quite unique with HyGen when we compare to other electrolyzer technology companies, is that most tend to be focused on one or two of the elements. So if you think about the stack, we have the membrane, the catalyst, the coating, and the bipolar plates. And usual teams will have expertise across one or two of those elements, whereas we have expertise and IP across them all, which is why we've been able to build a more efficient system at a lower cost, because we can co-optimize all of our elements simultaneously. So all this to say, we are specialized in the stack, but we can either sell a stack individually, we can sell a stack in an entire electrolyzer, and we also have partners with whom we collaborate if we want to actually sell the entire stack, electrolyzer, and balance of plant system.
Yeah, very, 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 very interesting. So there's a bit more like what's next for you guys.
Well, we just actually last month, the Monday of the week of the finals of Cleantech Open, we announced the close of our pre-series A. So we closed a $5 million round. And this is going to bring us in 2026. We are scaling our commercial team. And from a manufacturing perspective, we are going to be bringing our 2 megawatt manual production line to a 20 megawatt semi-automated production line. So that's going to allow us to increase our production capacity quite significantly. And we're also building from the R&D side. We are building our 250 kilowatt AEM stack, so a single stack at a capacity of 250 kilowatts. So if you know anything about electrolyzers, you can stack the stacks to build a bigger system. So if you have 25 kilowatt stacks, you can stack 10 of them and make a 250 kilowatt capacity. But growing the capacity size allows you to produce more on a smaller footprint, have fewer components, have it more contained. But as you grow electrolyzer stacks, efficiency tends to go down because then you have a larger membrane, then you have the membrane can get, holes poked into it if we're simplifying the process. So that's why we have to go incrementally. We have to grow incrementally, but that is our goal, to grow the single stack size nonetheless. So that's another 2026 goal. And obviously we have current deployments and pilot projects and about a little over a dozen LOIs, MOUs, and or signed contracts. But naturally, more is better. So that's the commercial scaling is a big part of 2026. As I mentioned, the team is growing. The vast majority of our team is in India or Southeast Asia. That's where our founders were, and as with most startups, we've been founder-led sales for the past few years. So growing the global footprint of HyGen is another priority.
Fantastic. How the community of listeners, investors, founders listening to this video today can help you guys?
Well, not to be repetitive, but I will be. Naturally, any industrial users who are currently using hydrogen and getting it shipped in through cylinders, that we'd love connections. We'd love connections to those people, to do a first analysis to see if it makes economic sense to instead have an electrolyzer. We're not in the business of making people pay more for hydrogen. If their shipping is 10 kilometers, then it probably won't make sense. But if it's 500, like a lot of them, then it will. So doing a first economic analysis and just having discussions regarding their needs, what they require from hydrogen, and how they use it, just so we can better understand their customer use case. Pilot projects like that is certainly very important. And from an investor perspective, naturally, we just closed, but these are always important relationships to have. And if any investors would be interested in hearing more about the space and being contacted for our next round for the Series A, then obviously we would be happy to have those discussions too.
Fantastic. Thank you so much, Natalie, for your time, for all the amazing, I would say, journey, effort, time that you put into HyGen. I think it's very exciting and fantastic to see again a team of wonderful people like really pushing something important and can be definitely a great impact as well. So, guys, thank you so much. I don't know if you have any question? Who is left? Just Joshua, and the rest disappeared.
Yeah, well, I think we passed our time, so I think a few people had to jump off. But I would just say thank you very much for having us. It's been a pleasure.
Yeah, thank you so much, everyone, and Beth. See you next time. I guess she's not there anymore, but good luck. And as I mentioned, feel free to connect directly with me as well. We know also people in the industry world. There's potentially opportunities to support you guys as well in the future.
Thanks again for joining us on the Tech4Climate Podcast. I hope you enjoyed the show. Stay tuned next week for more climate tech insights. In the meantime, head on over to our webpage at startupbasecamp.org, where we have lots more insights and resources for anyone wanting to get involved in climate tech. If you find our resources useful, please consider donating to support our small self-funded team. Don't forget to subscribe and share with your friends. And see you next time.